about visual grouping in menu interfaces. I'm going to argue that menu interfaces are pretty core still to human-computer interaction, and the visual design of them is also very core. So when you think back to when you were first exposed to HCI, many of you may have seen or be inspired by things like this. This is the parking payment machine at Georgia Tech, and as you can see, the layout is challenging. So obviously in current user interfaces, there has been considerable thought given to how to arrange menus. So here are just two examples. One is from the iPad, and the other is from Microsoft Word. In both of these examples, what you can see here is that there's a series of menu options which the user can select from. These options are arranged into semantic subgroups, so things that kind of go together are grouped together. And then additional supplementary visual grouping cues are used to reinforce and make that structure pop out at you, so you can clearly and easily see the boundaries between these subgroups, right? So here's the research question. It's very simple. It's a note. Here is the one on the left, which has the visual grouping cues, and here is the one on the right, the same thing with the lines removed. Which is better? Is the visual grouping actually helpful to users? And the thing that's nice about this design problem is that it's very clear what we're trying to do here. We're trying to help people find stuff as quickly and easily as possible, right? So let's go back to the iPad example. So this is a key point. So when you look at this, the top group, right, that's radios. The next group is notifications and everything else, right? So we've known about this for a long time. Information foraging theory, so the work of Peter Paroli and Stuart Card. They've done fantastic work here. And this work is essentially dealing with this problem that thinking about semantic structure and the structuring of semantic labels is challenging. And you get work like Ed Chee's Bloodhound project from like 10 years ago, where they develop a tool where you specify a user's goal, point it towards a website, and then it tries to figure out what you're looking for. So the fact that this is something that the HCI community thinks about, getting this semantic structure right. So when we go back to the literature, that's the great thing about this menu search area is that we've been doing this work for 35 years. So you can go back to 1985 and read journal articles on this. And here we see an experiment that's pretty much like the one I'm going to present to you today, except what they don't do is have this poorly structured menu, so where the semantics are kind of broken. And that's, if you like, our little novel contribution here. So here's a visual representation of our design. We're going to get people to do what we refer to as known item menu selections. So I would ask you to find a particular item here, say eyeliner. And you would look for that label in the menu and then select it with the mouse. And what you see here is what we've got is a 2x2x2 design where we have a random order at the top. So we have the same labels, but they're just kind of jumbled up into where there's no logical order. And the bottom set where they're organized into semantic subgroups. We then have small and large subgroups. So we either have subgroups of 3 items each or 6 items each. We're controlling for the number of total items, so that necessarily changes the number of subgroups. And then the final thing is this thing of visual grouping or not visual grouping, whether we have these, in this case, boundary boxes or not. Right, results. Here's the results to digest. We're interested in search time, so how quickly users are at finding stuff. I'm going to walk you through. There's 3 main things to observe in this graph, hence the stars. So the first one is that organizing the content into semantically related groups helps. So this is slower than this, right? You can see that? The next thing is that visual grouping helped when menus were semantically organized and contained larger semantic subgroups. So this is slower than here. So this is when there are larger groups. And this kind of makes a bit of sense. So if you have this group of 6 items, with clearly defined boundary boxes. You look at one item in the group, go, that's not what I'm looking for, and you can then very quickly saccade over all of the items in that group and use the boundary boxes to help you out. So that's how you get the speed up, and it's a change in visual search strategy, which my colleague is going to talk more about in a moment. There's a third thing going on, which is kind of interesting, we think, which is that visual grouping actually hindered search when used inappropriately. So search times were slower when semantically unrelated items were grouped together. So this was faster, so this is when the stuff is all mixed up, and then you've got no boundary boxes. Hey, you're fast. I put boundary boxes around it, so this is putting boundary boxes around everything else. Suddenly you're confused. You're like, there must be some logic here, and you get stuck. So take-home point. Really, for this community, it's that boundary boxes, visual grouping cues, they're used everywhere, and they're sometimes used not very wisely. And my point here is that adding them to an already poorly organized menu will just make things worse. So to answer this question, I'd go for the one on the right. And I go for the one on the right for two reasons. One, the group sizes are very small. There's only 3 items per group, so you get very little benefit if you get the semantics right. But you've then got this kind of bag of everything at the end, and that's not going to help. So one on the right wins. If you like this topic, we've been quite busy on it for the last couple of years. So at CHI last year, we had a note and a paper on it, these top 2. And my colleague Shirley Chen at Birmingham will be presenting a full paper in a moment, where we move beyond empirical data to actually describe models to explain what's going on here. I'd like to thank my funders, and this is a project that's funding us. Thank you very much.
We've got 3 minutes for questions. If you can please use the mic, or you're trapped back there. Can you shout really loud?
Yeah, sure, I can try.
I can bring you the mic. Yeah, okay.
I guess.
Or else none of them will hear what you're saying.
Check. Project my voice. Right. So I'm not disputing any of the research. Just curious about one thing. I'm sure you're aware of George Miller's theory on chunking.
Yeah. Yep.
The ideal plus minus 2.
That's a memory capacity idea, though, right?
Right.
Yeah.
So, and you said that grouping semantically unrelated items is actually worse. But how do you reconcile these two theories?
I think they're quite. We can talk more about this later. I think they're dealing with quite different things. Okay. I think yes. Let's talk more about that offline. Okay.
I have a question if no one else has a question. So you have some, in your study, it was, you talked about them being semantically anchored or not, or semantically meaningful or not semantically meaningful when they're grouped. But in your example, you have, thank you. I should use my own rule about using a microphone. Sorry. You have some that are semantically, not semantically anchored, but semantically grouped, and some that aren't. So in the iPhone example, the top 3 are about radio, the second 3 are about notification, and it's just the bottom one that's kind of a random, meaningless semantically grouping. So can you kind of talk about that?
Yeah. So this could be a nice follow-up study. So yeah, we did the extreme points in the space, but to have a mixed condition would be a nice natural third condition. So that's something that we could look at in the future, and presumably it'd be somewhere in between. All things considered equal. Great. Wheels. Okay.
One more, yeah.
So have you looked at user-defined groupings versus like system-provided groupings?
No, we haven't in this experimental work. So that would be an issue with generating the materials. So I mean, this is a designed experiment. So we structured everything. But that would, again, be an interesting thing to look at. So where you could also move to more naturalistic materials as well. If you notice, the materials we used were kind of clearly categorized things that don't come from computer interfaces. So again, that would be another area that we could push to. Okay, thank you.